Bismillah ar-Rahman ar-Rahim. Today, inshallah, we're going to talk about switches and how they work in more details. Of course, we discussed that before. Today, we'll highlight how the switch works in details. What are the different designs in terms of the switch architecture? And there are two categorizations for the switch design. So first, as we have discussed before, the way that the switch works, unlike hub is not a smart device at all. Switch is slightly smarter in the sense that when it receives the frame, it checks the destination address and then it sends the frame only on the port that this destination address is connected to. But before that, as we have discussed, that there has to be some learning process at the beginning. So at the beginning, if the MAC table is empty completely, then the switch doesn't know where the destination address is connected to, in which case it will downgrade itself to a hub and it will start using the broadcast approach. Whenever it receives a frame, it just checks the MAC table. If the destination address does not exist, then it broadcasts. That's fundamentally how the switch works. When it receives a frame, it starts to learn that the source is connected to that port, and then it builds. This is the way that it builds the MAC table accumulatively. So whenever it receives a frame, first it checks the source address and makes sure that the source address exists in the port that this source is connected to in the MAC table. So it maps the port of the source to the destination address. And then it forwards the frame. And then the next frame, it will add more nodes to the MAC table until it learns all the devices. That's the way it learns, accumulatively. So based on the design of the switch, there are three actually types of categorization for the switches. I left the third one for the lab. So the first two categorizations are are based on the way that the switch forwards the frame. So there are two types of switch designs. One is store and forward, and one is cut through. So for store and forward, the switch actually stores the entire frame, and then it makes sure that this frame is correct by checking the frame check sequence, which is the last field in the frame before it actually forwards the frame. Okay, so it stores the entire frame, makes sure that everything is correct, and then it sends the entire frame on the port. Of course, on one hand, this has an advantage and disadvantage, because on one hand, you have to make sure that everything is correct before you send it. So this way, you don't send something that has some error. But on the other hand, storing the entire frame slows you down. Okay, so that's a trade-off. This is an advantage and disadvantage. The cut-through, on the other side, tries to speed up the forwarding by just checking the destination address, or at least small part of the frame. So the objective of the cut-through is just to forward the frames very fast. So it doesn't store the entire frame. It doesn't check that the frame has errors or not, and it delays that to the destination node. If the frame has an error, it relies on the fact that the destination node will figure this out. But for the switch, it actually forwards the frame very fast, either by checking only the destination address, which is what we call fast forwarding cut-through switches, or it has to store the first 64 bytes of the frame. Okay, and the first 64 bytes, why exactly 64? Is that through experiments they actually found that if there is any collision, it actually happens in the first 64 bytes. Okay. After that, the probability of collision is very, very low, close to zero. Okay. So that's why the switch has one particular type, which is called fragment-free switches. And for fragment-free switches, the switch stores the first 64 bytes, okay, and then it checks if it stores it successfully and it checks the destination address, then it forwards that. Again, it does not check for errors, because the error exists in the frame check sequence, which is at the very last end of the frame. right? But when it stores the 64 bytes, it makes sure that there is no collision, at least. So it's a trade-off. It's a compromise between very fast and, because speed is not always good. When you drive very fast, sometimes you can collide, sometimes you can you don't arrive to the destination at all. You make accidents and stuff like that. So it's not always good. Okay. So these are the types of switches based on the method of forwarding. There is another categorization for switches which is based on the storage. In both cases, there is some storage of the frame, whether it's the entire frame or 64 bytes of the frame. You have to store the frame. And to store the frame, there are two, again, types of switches. One is a port-based memory, and the other one is shared memory. For port-based memory, the switch actually uses queues at each port. So the way you store the frame is using queues. And as we have studied in computer architecture, queues is like first in, first out. So everything has to exit in order. So each port will have to have a queue. And the incoming frames, they get stored in the queue in order, and then they exit in order. As we said in the videos, the problem with that is what we call the head-of-line blocking. And the head-of-line blocking talks about the fact that if the frames have to exit in order, sometimes like this frame wants to get to this port, this output port, for example. But this output port is busy because it's busy forwarding another frame from another port. In that case, this frame will have to wait, right? The problem with that is that in any lineup, if the one in the first line has to wait for something, all the people behind him, they will be affected by this. So all the frames behind it, they have to wait as well. Even if that frame wants to go to another port which is currently empty, which is currently not busy, but it has to wait because it's a queue. So everything has to be processed in order. Mafhum? So this is the problem of the head-of-line blocking. This always exists when you have queues in the architecture of the switch. The other type is what we call shared memory. In that case, there's no queues. There's only RAM inside. And the frames, they get stored in the RAM, and as we know, the design of the RAM allows any device to store multiple frames at different locations and fetch these frames in a random fashion, which means that there is no order in that case. So you can put the frame at any point in time, whether it's coming from port 1 or port X, it doesn't matter, and whether it's going to port 1 or port X, it doesn't matter. And then you can fetch it at any point in time. The only drawback here is that the RAM, the design of the RAM is slightly complicated and it's more expensive. Okay, so these are two different designs. There is the port-based memory and there is the shared memory.
So the switch would have a RAM?
Well, the switch can, there are two types of switches. There is the port-based memory switches and there is the shared memory switches. The switch fabric has to have one of these two architectures. Okay? So that's, so this is how the switch works and the different categorization of switches. There is, of course, layer 2 switches or layer 3 switches, and the only thing that we need to know about layer 3 switches is that layer 3 switches, they act in between a router and a switch. So they do actually use IP address, they do use logical address and physical address, both at the same time for switching, even on the local area network. Okay? They use both the IP and the MAC layer for switching. So they are more intelligent than the layer 2 switches. Okay? So the first activity here tries to get us familiar with how the switch actually works. So you have a frame which is sent from one source to one destination. So from the address, you need to figure out where is the source and where is the destination. And then based on this MAC table, which is what the switch will consult to figure out whether it sends this frame to which port, it needs to perform a certain function, whether to send to one port or multiple ports or whatever. So you need to mark all the ports that will receive this frame. And then check whatever of these points that will apply in that case. Okay? Here you can check multiple boxes, and here you can check multiple boxes as well. Okay? So you need to think about which boxes you need to check. 0E will send the frame. It will reach to the hub. The hub will already send this as a broadcast. It will reach to 0F, which is the destination. So it's done. The job is done. But the switch will still pick it up. Once the switch picks it up, it will have to do something about it. Okay? So the switch will pick it up at port FA9. So the first thing the switch learns is that this source physical address is connected on port FA9. It will store this information in the MAC table before anything else. So it knows دلوقتي that 0E exists in FA9. So this is the first step. So now I learned something. The second step, it will check the destination address. Where is this destination address? It will consult the MAC table. The MAC table does not have this address stored in any of the ports. So what is the fallback scenario? Flood or broadcast to all connected ports. To all connected ports. So FA1 is connected, so it will send it. FA2 is not connected, it will not send it to FA2. It will send it to FA3. It will send it to 5. It will send it to 7, but not 9, because 9 is the port that the frame came from. That's it. The switch is done. So which of these apply? Which of these ones apply? Switch adds the source MAC address to the MAC table. That's what we had just done. So yes, the frame is broadcast frame. Pay attention to that. The frame is a broadcast frame. When is the frame broadcast frame?
The source, the destination is.
When the destination is all F's. Okay? Which is not the case. So this does not apply. The frame is a unicast frame and will be sent to a specific port. When is it sent to a specific port? If the destination address already exists in the table, which does not apply in this case. So that one does not apply. Frame is a unicast frame and will be flooded, which is what we have done now. Frame is a unicast frame, but it will be dropped. When is it? When does this one apply? The only case if the frame check sequence tells the switch that there is an error in this frame. I don't drop the frame because I cannot find the physical address. It can never happen in switches. Because I always have a fallback scenario flooded to all ports. But the only case when the frame is dropped is when the frame has an error. And the only way I figure this out is when I use store and forward. I store the entire frame, I check the frame check sequence, and then the frame check sequence tells me that this frame has an error. That's the only case when I drop it.
You said that it won't broadcast it to FA9 because it's the sending port.
Right.
But the destination is 0F, which is in FA9.
Right. So well, if we don't have a hub, we'll be in trouble. But try it any other scenario, and you will find that the frame will in fact reach to 0F regardless. Because if you put it, if you don't have a hub, then you have to connect this to another port. In which case, I will learn this port one way or another.
The switch already learned all the
ports. Yes.
It will still flood the...
No. If I learn all the physical addresses of all the devices connected to me, then I don't use flooding at all. I use flooding if one device sends me magically one destination address that I cannot find in the MAC table, then I will flood. I have no other choice.
لو انا عندي الديستنيشن سابق موجود عندي
بالماك table, then I will send to a specific port, only on that port.
حتى لو ما عندي بقى بس عندي
Yeah, like let's just assume that the destination address was 0B. If the destination address is 0B, do I have to flood? Unicast. It's a unicast to a specific port because the port already exists. So I'll send it only to FA3. That's it. Okay? The other thing you need to pay attention to is that this learning process is accumulative. So for example, if I have another frame, after this, if I have another frame with destination address 0E, in the first step I already put 0E in the MAC table. So in the next step, I will not flood. If the destination address is 0E, I will not flood. I will send to a specific port.
I understand that the switch, how does the hub forward it?
The hub is, as I said, it's a dumb device. It works from the physical layer point of view. It does not have any MAC layer.
I mean, does 0E message, frame to the hub will forward to all other ports?
Yes, he does not forward the frame. He forwards the signal. Okay, he deals with signals only.
Yes, I can.
Yes. Okay.
So the messages are sent from 0E to 0E?
Through the hub, yes. So
how does the switch get the message itself from the hub?
because the hub will broadcast the signal, so the switch will pick it up.
Yeah, but the message is sent to the destination first.
Yes, in the first step, أصلاً, yeah. Yes.
We wouldn't have the MAC address of the destination in the MAC table by the end.
By the end? No, from this, no, you will flood it to all. Only now when 0F will get the frame, right? Depending on the protocol that 0F uses, the 0F may send some reply back to 0E. Typically, that's what happens. If 0F sends, then the frame will reach to the switch, and the switch will learn from the source address that 0F is connected also to port FA9. So it will put 0F here.
So
That's why there are two locations in FA9.
Okay. And then we should have a MAC address in all the check boxes, right?
Right. Okay? So
if F0F
okay, so this activity here talks about the difference between store and forward and cut through. And I should have added here that this slight difference between the fast forwarding and the fragment free, which are both part of cut through. So we should add here some, but we'll discuss it together. So you need to identify which switch design best fits some of these sentences. And some of them are a little bit tricky, so you need to think carefully about that. All right, so the first one is easy, right? So it buffers the entire frame. This is a store and forward. Checks the frame for errors. This is a store and forward. No error checking frames is performed. This is a cut through. That's okay. It's a great method to use to conserve bandwidth. I would say both apply. Why? Because for store and forward, you have to store the entire frame, which slows you down. Yes, so that's a disadvantage. But on the other side, when you send the frame, you actually utilize the bandwidth efficiently because you don't send except the ones that have no errors. Right? Unlike cut through, because cut through may send many frames in error, in which case it will cause many retransmissions over the line. Okay? So in that case, store and forward has some advantage and disadvantage when it comes to preserving the bandwidth. And as well cut through, because if the probability of error is very high, then cut through is very bad. But if the probability of error is very low, then cut through is the best, and cut through will conserve the bandwidth much more efficiently than the store and forward, because if the probability of error is very low, then cut through will forward things very fast, in which case you will have more bandwidth. Okay, so the bandwidth or the transmission between the devices will be much faster in that case.
So, but storing the data in the switch doesn't affect bandwidth?
It does, because the storage itself takes time.
But that affects the speed. Bandwidth is...
Yes, it affects the speed. Yeah, well, it depends. Yes, the definition of bandwidth that we talk about here is the throughput.
Yeah,
is the actual throughput.
So it affects...
Yes, so in that case it does affect. Because if it's the bandwidth is something theoretical. And in that case, it's not affected by either. Okay? But here we talk about the speed of communication between any two devices. Okay? So the destination network interface card discards any incomplete. So the only way for the incomplete frames to happen is in the case of a cut through, because in the case of store and forward, you don't send anything incomplete. You have to store the entire frame and send it as one unit. So in that case, it's cut through. The faster switching method, but may produce some errors. So in that case, it's also cut through. So that's another slightly tricky activity that you may have multiple solutions here, depending on how you look at these sentences. And this talks about, of course, the types of cables. Of course, we have gone through that in the lab, the straight-through cable and crossover cable. And so you need to identify which types of cables that the switch needs to use, and what, forwarding method that the switch needs to use at certain point in time. Okay, so you also need to match these boxes to some of these sentences. So very quickly, the wording here is a bit tricky. So you need to watch out, and in fact it's not complete. It's a little bit vague. Let's see. First, the cabling. This is clear. The cabling is straight through. So this is straight through. That's clear. To find PC2, where PC2 is located.
Broadcast.
Well, I didn't tell you whether PC1 now. Does that mean that PC1 doesn't know the MAC address of PC2? Or it does, but it's just that the switch doesn't know the MAC address. The wording here is not 100% clear. If PC1, if this means that PC1 does not know the MAC address of PC2, then PC1 will do what? Will send an ERP request to get the physical address of PC2. In that case, this ERP request is in the form of broadcast.
But
if PC1 knows the MAC address, then in that case, this will be unicast, because I know the MAC address. The switch, if it doesn't know where this MAC address is located, then it will broadcast, or it will flood to all ports. Okay? So we assume that from this wording that PC1 doesn't know the physical address of PC2. But the wording here has to be absolutely clear. So I have to tell you that PC1 doesn't know the MAC address of PC2. What does it do? Kid. It has to be clear. So PC2 will respond back to PC1, and in that case, the reply is always a unicast, because from the broadcast, I got the source address, so I know how to reply back. If PC2 receives only half of the data in the frame, it will, and this happens in the case of cut through, so it will discard it. And this is PC2. The switch doesn't discard it unless it has an error. And this happens in the case of store and forward, not in the case of cut through. The last one, if PC2 receives many damaged frames, then it will switch back to Y, because this indicates that the probability of error is very high. So it needs to switch to something that's more robust, and it does the error checking.